Imagine an asteroid hurtling through space, a rocky giant with the power to reshape entire landscapes and disrupt the lives of millions. It's not just science fiction. This is a reality astronomers are keeping a close eye on. Named Apophis, after the ancient Egyptian god of chaos, this asteroid has captured the world's attention since it was discovered in 2004. Its size alone, nearly 370 meters across, or as tall as the Empire State Building, makes it a formidable presence in our solar system. Back when Apophis was first spotted, early calculations showed a small but startling chance that it could collide with Earth in 2029. This prediction sparked intense debates, leading scientists, governments, and the public to consider the unthinkable. An asteroid strike that could unleash the power of hundreds of nuclear bombs. However, with more observations, NASA has since revised its predictions, saying Apophis is no longer a threat for 2029 or even for decades to come. But is there more to the story? Apophis's 2029 encounter may not spell immediate danger, but its path could change in ways we're only beginning to understand. And with each close pass, there's a chance the asteroid's trajectory could shift, bringing it into a more dangerous orbit in the future. So, today, we're diving into the science, the risks, and the very real potential consequences of Apophis's close approaches. Are we fully prepared, or could this asteroid still catch us off guard? The story of Apophis began nearly 2 decades ago when astronomers at the Kitt Peak National Observatory discovered this massive space rock in June 2004. The initial data was shocking. Apophis was on a collision course with Earth, or so it seemed. Early models even gave it a 2.7% chance of striking Earth on April 13, 2029, making it the most significant asteroid threat we had ever faced. This revelation ignited a global reaction. Astronomers scrambled to understand Apophis's orbit, refining their models and observing it night after night. Over time, they gathered enough data to rule out an impact in 2029, estimating it would instead pass within 31,000 kilometers of Earth, closer than many of our satellites. Yet, even though NASA now says it's safe for the 2029 pass, there's still some uncertainty surrounding Apophis's future. Why? Because each close encounter with Earth's gravitational field could alter its path, setting the stage for a potential impact decades down the road. Understanding Apophis means facing the limitations of our models and coming to grips with how unpredictable these cosmic visitors can be. You might be asking, if NASA says there's no immediate threat, why do we still consider Apophis a risk? The answer lies in something called the keyhole effect. In 2029, as Apophis makes its incredibly close approach, it will enter what scientists call a gravitational keyhole. This tiny region in space acts almost like a cosmic slingshot. If Apophis were to pass through just the right spot, within this keyhole, Earth's gravity could slightly nudge its orbit, putting it on a future collision course for a later date, potentially as soon as 2068. While current calculations suggest Apophis is unlikely to pass through this exact spot, the possibility is enough to warrant careful monitoring. Apophis is considered a potentially hazardous asteroid because of its size, speed, and path. It's not just a space rock. It's a high-speed missile moving at about 30 kilometers per second. A single miscalculation or unexpected influence, like a gravitational tug from another planet, could lead to a drastically different outcome. And with an object this large, even a minor course adjustment could have major consequences for Earth. If Apophis were to impact Earth, we would be dealing with a natural disaster unlike anything seen in human history. The energy released could flatten cities, create massive tsunamis, and even alter our climate. We're talking about the potential for continental-scale damage. The question isn't just, will it hit? But also, what if we're wrong? What sets Apophis apart from other near-Earth asteroids? First, its sheer size. Measuring around 370 meters across, Apophis is far larger than most objects that approach Earth. The energy it could unleash on impact is equivalent to hundreds of megatons, about 10 times more powerful than the Tunguska event of 1908, which leveled an area of forest in Siberia larger than the city of Los Angeles. Apophis wouldn't just make a crater. It would reshape entire regions, potentially changing coastlines, destroying infrastructure, and releasing debris into the atmosphere that could alter our climate for years. But Apophis is special for another reason, too. Its orbit brings it close enough to Earth that we can actually observe it in detail, unlike most asteroids, which are too far away for such precision. In fact, the 2029 approach will be so close that we'll be able to study Apophis without telescopes. In some regions, you'll be able to see it with the naked eye, like a fast-moving star in the night sky. And each pass brings an opportunity and a challenge. The more we observe, the more data we gather to refine our understanding of its trajectory and potential threat. If Apophis, or any asteroid of similar size, were on a collision course with Earth, how prepared are we to stop it? Right now, NASA and other space agencies are working hard on asteroid defense strategies. The DART mission, or Double Asteroid Redirection Test, is a recent effort to test our ability to deflect an asteroid by crashing a spacecraft into it. The goal? To nudge its path just enough to avoid an impact with Earth. It's a groundbreaking experiment, but it's also just the beginning. The key to any defense plan is early detection. Apophis serves as a test case for the importance of accurate tracking. If we spot a threat years in advance, we have options, deflection, diversion, or other technologies that are still being developed. But if we're wrong or catch it too late, the options become far fewer, and the consequences much more dire. Many scientists are calling for increased funding and collaboration on asteroid detection and deflection technology. Apophis's close pass in 2029 could be an ideal time to practice deflection strategies, even if it's only a simulation, to prepare for a future in which a close encounter turns into a direct threat. Let's get to the heart of it. What if Apophis did hit Earth? The result would depend heavily on the impact location. If it struck land, we'd see an explosion equivalent to hundreds of nuclear bombs, creating a crater miles wide. Shockwaves would radiate outward, leveling forests, buildings, and infrastructure over hundreds of kilometers. Cities within the impact zone would be reduced to rubble, and secondary effects, like fires and dust clouds, would spread even further. If Apophis landed in the ocean, the results would be equally catastrophic, though in a different way. An ocean impact would generate massive tsunamis, potentially hundreds of meters high, spreading destruction across coastal regions worldwide. These waves could inundate cities and regions far from the impact point, flooding areas and sweeping debris far inland. The devastation wouldn't be limited to the immediate area. Communities thousands of miles away could feel the effects. And beyond the direct impact, there's the environmental toll. Dust and debris kicked up into the atmosphere could block sunlight, triggering a global cooling effect similar to a nuclear winter. This could disrupt agriculture, threaten food supplies, and alter global weather patterns for years. The ripple effects of an Apophis impact would be felt worldwide, affecting ecosystems, economies, and human life in profound ways. For now, Apophis is not on a direct collision course. NASA's current predictions indicate that the asteroid will pass safely by in 2029, and its next potential close approach in 2068 has a low probability of impact. But Apophis remains a symbol of the unpredictable nature of space and the potential for future surprises. Every pass it makes gives us a chance to gather data, refine our models, and develop our defense strategies.